In this lecture, we're going to cover the integumentary system. And there's three main foci for this lecture. So the first thing we want to focus on is the skin and the hypodermis. That's number one. The second thing is the appendages to the skin. And then finally, the third thing are to focus on disorders of the integumentary system. So let's go ahead and get started on the first one here, the skin and the hypodermis. Okay, so before we do that, we should focus on the fact, what is the integumentary system? It's a question we want to think about. And really, it's composed of two different parts. So the skin, right, number one, and then two, the appendages of the skin. So things like sweat glands, oil glands, hair, nails, things of that nature. If we look at the skin, really it's sort of amazing because it's the largest organ in our body, and it accounts for about 7% of our weight. It varies in thickness, right, divided into two parts, the epidermis and the dermis. And then finally, there's something called the hypodermis that lies deep to the dermis, if we use our directional terms. The hypodermis technically is not part of this system, but it's so closely related and really plays a large role that we sort of include in this lecture anyway. Okay, so what is gross anatomy of the integumentary system, and what are the 5 most important functions of the skin? So if we look at the gross anatomy, we see a few different structures here. So you'll see that we see the epidermis right here. If we go deep to that, we'll see the dermis. Again, that's part of the system formal, right? The hypodermis is not really part of the system, but we'll talk about it a little bit more later. It's related to the system. And then finally, deep fascia and then muscle underneath. So we're really going to focus most of our discussion on these first two, but we will delve into the hypodermis a little bit as well. So that's the gross anatomy. If we zoom in a little bit here and say, what are the 5 important functions of this system? Well, 1 is protection. 2 is to regulate body temperature. The third one is excretion, right, of salts, the water we lose through sweat. The fourth one is production of vitamin D. When the epidermal cells are exposed to UV radiation, they synthesize vitamin D, which is very important in calcium absorption. So that's something that we'll mention a little bit. Then the last one, when you combine it with the nervous system, we talk about sensory reception. Okay. So what is the structure of the skin? Let's focus on that. And I grade some terms out here, you'll see. So we're not going to focus on the terms that are grayed out, but I want to at least leave them there so you could see that they do exist. But let's focus on these here. So we're going to focus on the epidermis. When we look at that epidermal layer, that top layer, that's actually composed of epithelial cells. If we go ahead and zoom into the next layer, the dermis, the top portion of the dermis is called the papillary dermis. And this is the part of the dermis that has that sort of wavy appearance at the top, the projections that are projecting up into the dermis. And the papillary dermis is something that is composed of areolar connective tissue. Below that, the bottom part of the dermis is something called the reticular dermis. And this is composed of dense irregular connective tissue. And this is interesting because this is actually the area that if someone gains a lot of weight, or let's say they're pregnant and they gain weight through pregnancy, they'll have these things, these striae, or these things that are called stretch marks that occur. And really that's because you're stretching the collagen within that layer to its maximal amount of stretchability, for lack of a better word. And really you're stretching it out and it can't really quite return to its normal form, if that makes sense. If any of you have tattoos, the ink actually is deposited all the way down into this dermal layer as well. So that's sort of a neat little practical connection. The next layer down, again, not part of the integumentary system formal, but it's called the hypodermis. And that is composed of areolar and adipose connective tissue. So you want to really link each of these different types of tissues to these different layers. Okay, so if we go beyond the skin here and we talk about the appendages of the skin, you'll see these things pop up here, right? So we have these, we have hair, we have these different oil glands, sweat glands. On the top left here, you'll notice that popped up too as well. You have a hair shaft. We're going to talk about some of these appendages in this lecture as well because they are part of this system. And then what I want to note here too is that we have these top things called these dermal papillae, and what they literally mean are nipples. And they sort of look like that actually if you look up. These are projections going up from the dermis into the epidermis, and really they help a few different things. But one thing they really help with is sort of forming that solid connection between the dermis and the epidermis. We'll talk about how that can be compromised at times, but really it helps form a strong connection between those two layers. Something else that's sort of neat to notice is that you do have vasculature, right? So you do have vasculature here, you do have vasculature here. And something else to notice is that you do have these sweat pores right over here that go up along these epidermal ridges. So when we talk about this dermal papillae and the dermis is forming these ridges, those ridges actually extend up into the epidermis as well. And on top of those ridges, right, so right up here on the top, you see it right here as well, right there. On those ridges, what you'll notice, you have these sweat pores. And so that's sort of neat because when you touch something with your hand, that's what leaves a fingerprint. Something that's used in, crime scene investigations, things of that nature. So it's sort of neat. It's those sweat pores on top of those epidermal ridges, which come from those dermal ridges. And that really gives you the fingerprint mark that you see often. Okay, so what is the role of blood within the integumentary system? There's sort of two roles that I would think of. And so one of the roles, the first role, is obviously to deliver nutrients, to the skin, right? That's one role. Keep in mind, the top layer of the skin is dead, right? But, delivers nutrients, cells of the immune system, things of that nature. But the second thing really is something we alluded to before, and that's number two is going to be temperature regulation. About 5% of your blood is actually found, within this integumentary system. And what can happen is the body can actually withdraw some of that blood if it needs to warm up the internal organs, or if it's very hot out, what can happen is blood can increase to the system, and hence the heat from that blood can be sort of radiated away from your body. So temperature control is a very interesting thing as well. Something else that's sort of interesting too is that sort of a practical example on the top left here. What you can notice is that we can often deliver chemicals to our body through the skin. So things that are very nonpolar, if you will. Things such as oils, chemicals such as like nicotine. And so what you see here is something called a nicotine patch. And really what you can do here is you can apply this to the skin. It'll be absorbed right through the dermis, something that's very interesting. Other things don't absorb as easily, but we might want to apply those as well. And so nicotine patch is very standard today, but it would be nice to have something like an insulin patch too. And so some groups are experimenting with an insulin patch, but really with that, insulin is not readily absorbed through the epidermis, so the patch would almost have to have little spikes on it. And so if I were to sort of try to draw that, on our skin model here, if you applied the patch, pretend this is a patch, it would have to have little spikes coming through it, and hopefully they wouldn't be deep enough to hit the nerves, obviously, but little spikes coming through it to deliver that insulin directly into the dermis. So that's something that people are experimenting with if you want to have like an insulin patch. Okay, so let's move on to what is the gross anatomy of skin and what are all these lines? So the gross anatomy we sort of talked about a little bit already, right? But what are all these lines? You might think, what is he talking about, all these lines? What are all these lines? The one on the top left we talked about a little bit already, right? These are the ridges. So these are those epidermal ridges that you see. And again, there's sweat glands on top of those, and that's what gives you this nice fingerprint structure here. So we sort of alluded to that on the previous slide. If we look at the very right-hand side of this slide, there's also things that are called flexure lines. And these are lines that penetrate all the way down to the dermis. And these are just areas of the body that are flexed, sort of how the term implies, right? Or bent a lot. So you'll see them around joints a lot. And these are lines that are, not due to aging or anything like that, but they're just permanent lines, depressions in your skin, all the way down to the dermis again, because of the fact that these are where joints are. So that's sort of neat. There's also things that are called cleavage lines, the middle one here, and these are in the reticular dermis, and these are very neat actually. So these are sort of like the directionality of the collagen fibers in this layer, and what it does is if a surgeon's going to go in with a knife, what they want to do, so I'll draw a little knife here, it's not the best, right? Pretend this is a knife, right? Here's sort of the blade right there by the arrow, and pretend they're going in, they want to cut parallel to these lines. In other words, the same direction of these lines. So what that does is that aids in healing. If they were to cut perpendicular to these lines, in other words, the direction of their slice, if it made a cross with one of these lines, that would not be a good thing. So if you're going to cut into abdomen here, really, if I draw a line here, you'd want to be cutting in this direction like this, right? It aids in healing. So it's sort of a neat practical application. Okay, so let's turn our attention now to what epidermal cells exist, right? And what are the layers that are present here? Okay, so if we focus on the deepest layer of the epithelium right now, what you'll see, or the epidermis, what you'll see here is that we have a layer called the stratum basale, and that's right here. This is the deepest of the epidermal layers, and it has cells that are very highly active in terms of mitosis. So really, if you look here, you'll see that there's a lot of stem cells here. These are producing the cells that are going to migrate up into the upper layers of the epidermis. Occasionally you'll see melanocytes or dendritic cells, but really you'll see a lot of stem cells in this region. If you work your way up, the next region up here you'll see is the stratum spinosum, and that has several layers of keratinocytes, keratinocytes, a little hard to say, it's a mouthful. And these are really unified by desmosomes. Remember, desmosomes are their linkages between cells that give strength. And so that's something that's really, sort of neat. The reason they have this name stratum spinosum, having a hard time speaking today, sorry, is because when you prepare these tissues for section, actually they'll sort of dehydrate a little bit sometimes, and they'll maintain cell connections between the desmosomes, and it gives the cells sort of like a spiky appearance sometimes. And that's where you get this word spinosum, sort of means spikes. So it's interesting. It'll also contain bundles of intermediate filaments that are made of pre-keratin, something else you'll see here. Obviously the picture on the left, this one over here that I'm referring to on the left a lot, is an actual microscope image. The one on the right is sort of a cartoon image that we'll refer to in a second. We look at some of the more of the detailed cells. Okay, if we work our way up again, we see the stratum granulosum. It's about 1 to 5 layers of flattened cells. The organelles are starting to deteriorate here because you're starting to have some cell death, because again you're not getting enough vasculature up in this region, not enough the materials that the blood is delivering cannot make it up to this upper layer as well, so you're starting to get some death here. Finally, the top layer here is the stratum corneum, and this is the most superficial layer and has many layers of dead cells that you can see. There's a lot of fatty deposits here as well, glycolipids. You'll see those in the extracellular space. And again, that helps with insulation a little bit, so that's a sort of a neat phenomena there. Okay, let's focus our attention on the right-hand side of the slide here, and I want to go through a few of these different cells that you'll see. Okay, so if you focus your attention again on the right-hand side of the screen here, we'll go through a few different types of cells here. The first type of cell you'll see is this one right here in the middle bottom, called a tactile epithelial cell, or a Merkel cell. You'll see that this cell is attached to a sensory nerve ending, so it's really used for touch, right? Touch sensitivity. If you look a little bit to the right here, you'll see something called a melanocyte, and this is the cell that produces the pigment melanin. This is what gives our skin color. If people have very light skin complexion, what happens is a lot of this melanin is destroyed as it's produced. It doesn't make it up into the higher layers of the keratinocytes. However, if someone has darker complexion, this melanin accumulates within those basal layers of the keratinocytes. I have a very hard time saying that word today, keratinocytes. And so if someone has a darker complexion, that melanin, you'll see it sort of accumulating here. So it's this blue fluid, that's how it's drawn in this diagram here. And you'll see it leaking up into some of the basal layers of the keratinocytes, which are right down in here. Something else I want to mention here is you'll also notice cells here called dendritic cells. And these basically take up foreign proteins, right? So foreign invaders, right? So an immune defense cell here, and they travel to the lymph nodes where they end where they end up destroying those types of cells, and those type of foreign proteins, and they generate an immune response. So on the left, you see really the layers that exist, and it mentions the cells within those descriptions too. But on the right, in the cartoon version, you see all the different types of cells that you want to make sure that you know. Okay, so take a little sidebar here a second. What is thick skin and how is it different from thin skin? What I showed you on the previous slide is a diagram of thin skin. So just sort of make a note on that previous slide. It's called thin skin. And that's pretty much all your skin in your body, right? That's pretty much thin skin. Now there are some exceptions, some things that are called thick skin. And one example is the soles of your feet. That's a thicker skin, and it has an extra layer that you'll notice that wasn't in the previous slide. And I highlighted that here in red, right here. Okay, so that's an extra layer that it has. That's stratum lucidum. That's an extra layer that thick skin has. And you'll notice that the stratum corneum, this top layer here is much thicker than it was in the thin skin on the previous slide. So that's something that you'll notice, sort of a difference there. Something else to point out that's sort of interesting, again, sort of a side note, but something important to note, that a lot of times if people are playing athletics and they have a lot of, rubbing between the soles of their feet and their shoes, or someone's running a marathon, something like that, they'll often get blisters right here, like you see on the bottom left. And really what that is those blisters are fluid that accumulates between the dermis and the epidermis. And eventually what happens is they should be connected, right, through those dermal papillae, but the dermis and the epidermis actually separate, which is a very interesting phenomenon. You get these blisters that form. It can be quite painful, actually, if you've had that before. Okay, so let's focus, now that we did the epidermis, we focused on the dermis, let's go one layer deep, right, one layer more deep, and talk about the hypodermis. Just to mention a few things about this. So it's deep to the skin, right? Remember, deep means down more towards the center of the body. And it's also called the superficial fascia. It contains areolar connective tissue as well as adipose connective tissue, and it anchors the skin to underlying structures, that additional fascia, and then finally the muscle. Really helps insulate the body, sort of neat. And it has a different distribution in males and females, which is really sort of interesting as well. And what I mean by this is this: if someone gains weight, right, if someone's gaining weight over time, which happens to many of us, if that happens, what happens is that you actually get a thickening of the hypodermis, right? You get a thickening of the hypodermis. So if you're gaining weight and your hypodermis is thickening, there's a different distribution in terms of how it thickens in men and women. So if you're looking at men here, in men the hypodermis really thickens around the belly region, right? So sort of the abdomen region. And that's really, your book even suggests this, that's what we call that beer belly, right? That develops in men often. In females, on the other hand, when you have a thickening of the hypodermis, what happens is it really accumulates more around the thighs and the breast area. And your book elaborates on this. So it's something that's sort of, just interesting, a difference between the sexes in this regard to the hypodermis. Okay, so let's turn our attention to this question now. So what pigments affect skin color? So I'm sure well aware, right? We all have different complexions. And really the question is, how does this happen? What contributes to this? Well, there's three main pigments that contribute to skin color. One of them is melanin. It's the most important pigment that we'll talk about. It's made from a compound called tyrosine. And melanin basically accumulates more. You'll have more melanin production in individuals that have darker skin as opposed to individuals that have lighter skin. Although you have the same amount of melanocytes, which is sort of interesting, but the total accumulation of melanin is more in an individual with darker skin. There's other pigments as well. There's keratin, and there's hemoglobin. And something that's interesting, if we look at someone that has a lighter complexion, so someone maybe that's Caucasian, let's say, their skin contains little melanin for the reason I mentioned before. It's sort of destroyed over time. It doesn't really migrate up into those different cells. But instead what you see is you don't see that dark melanin, but rather you see a crimson color, and that crimson color is basically the color of blood, right? That's sort of showing through. And so you could tell, for these reasons, you have these different players here. You have how well can you see the hemoglobin, how much melanin is accumulating. You can really have an infinite number of complexions of skin, based on this reason and because of these three pigments. Okay, so again, talking about pigments, let's talk about another practical application. So what are moles and freckles? And we might say, well, we know what that is, right? I'm sure we all do. But let's talk about how they form. That's sort of interesting. Okay, so if we look at a mole, here's a famous example of a person, right? So Eva Mendes, I believe is her name, that has a very famous mole. We have another person, I believe this is Prince William, right, from the English royal family, and he has freckles, right? So you can see his freckles are not showing as well here because he has freckles all over his face right there. How do these form? It's very interesting. So they both form because of an accumulation of melanin. They both form for that reason, but in slightly different manners. So when we have a mole, what that is the cluster of melanocytes that are transformed into melanin-containing cells. So the melanin is like staying within the melanocytes, which usually doesn't do that, as we discussed before. And what happens is, this is located really in the basal layer of the epidermis, the top layers of the dermis, you get this accumulation, and that accumulation of melanocytes or melanin within the melanocytes ends up producing that mole that you see. On the other hand, if you look at freckles, those actually result from sort of damage to the skin from UV exposure. and they're restricted to the basal layer of the epidermis. So you get this damage to the skin, and what happens is the body's producing more melanin to combat that UV damage, right? Because melanin can absorb UV, and you see sometimes that results in these patches on the skin, which we call freckles. It happens much more frequently in individuals with light complexion, although it can happen, with individuals with darker complexion as well. So that's sort of a neat practical application. Okay, let's go ahead and turn our attention now to the appendages of the skin. We're going to talk a little bit about nails, a little bit about hair. So nails are made out of hard keratinized dead cells. And it's sort of interesting because the nails are made out of something called hard keratin, and that really predominates in nails and also in hair that we'll talk about in a second. And that differs from soft keratin, which you find in your epidermis, right? So to your skin throughout your body. And it differs in two ways. One way the hard keratin differs is that the hard keratin is hard, right? It's much tougher than the soft keratin. But the other way it differs is that it does not slough off, right? It does not slough off at all. So you're not really losing your nails at all, whereas it's very easy to have the soft keratin slough off. For example, in your hair or your head, that could happen because you get dandruff, right? That's the soft keratin sloughing off. But the hard keratin doesn't really have that happen. So that's sort of an interesting note about nails. Let's take a look at some of the components of the nail. You'll see that if we start from left and move to the right, that the nail has something called a free edge. And this is the part of the nail that you would clip off if you were clipping your nails. If you move to the right, we have a nail plate. If you move further, we have the cuticle, right? The cuticle. And then you have something called the proximal nail fold. And then after that, you have something called the nail root, right? And this is the part of the nail that's actually embedded into the skin, that nail root. And then just above that, you have something called the nail matrix. The nail matrix is the part where you actually get active growth of the nail. Okay, so the nail matrix is where you're getting active growth. You'll also see something at the top here called the lateral nail fold. And this is something where you don't want your nail growing into that, right? And if you do get your nail growing into that, that's that painful situation where you have an ingrown nail. Okay, so those are some different components here. The nail also, if we look at the bottom here, rests upon something called a nail bed. And then obviously you see your bone here within your finger, just to give you a reference point. Those are some components of the nail. So another question here is, what is hair? Let's turn attention to hair, right, because it's part of this system. And what are hair follicles? So hair is basically a flexible strand of dead cell, right? Dead keratinized cell. That's why when you cut your hair, it doesn't hurt, right? Fortunately. It's hard keratin, it's tough, it's durable. And there's two main parts to hair. There's the root that's embedded in your skin, and there's the shaft that projects up, which is the hair that you see. Hair has three different concentric layers here of keratinized cells. Something called the medulla, the central core, which you'll see in a second, the cortex that surrounds the medulla, and the cuticle, the outermost layer. And you can see those here when you focus on it. So if you focus on this, you'll see again here, the medulla is right in the middle, the cortex is surrounding that, and the cuticle is outside of that as well. The cuticle is part of the hair that is a single layer of cells, and it's very heavily keratinized. And because of that, the cuticle protects these bottom two layers here, right? The cortex and the medulla. And something that's sort of interesting is as your hair ages, right? So the tips of your hair on your head would be the oldest hair, right? Because it's been there the longest. So as it ages, that cuticle is going to wear down, and hence what happens is the cortex and the medulla can actually sort of have like abrasion happen to them. And the keratin fibrils within the cortex and the medulla can become abraded and start to fray. And really that's what we say when someone says that they have split ends, right? That's sort of how that happens. That's sort of an interesting phenomena. If we start working our way out here, you'll see that we have an internal root sheath, an external root sheath. We have this follicle wall here. We have a glassy membrane. And then we have peripheral connective tissue that's this like fibrous sheath. So different structures of the hair. Okay, if we turn our attention to this picture in the middle, you'll see that you have a hair bulb, right? So this is the hair actually, extending into the head. You have the hair root. You have sebaceous glands, right? You have a muscle called an erector pili. That's the muscle that helps your hair stand on end if someone gets excited or afraid. You can visualize that response, greatly when you're talking about like an animal maybe, but people can do that too. And then you have the shaft, the hair shaft that's extending above the skin line. This right here is basically showing you a side view, right? So sort of a longitudinal view, if we want to use our proper terminology. It's the exact same thing I showed you on the previous slide, just a different perspective. The previous slide, if we just back up here, is sort of a cross section, right? A cross section, like someone's cutting your hair, like that type of look. So you're looking down into the hair. This one here is a longitudinal view. Okay. Finally, let's turn our focus here to disorders of the integumentary system. We'll talk about burns, and then we'll talk about certain types of cancers. Okay, so one disorder, actually wouldn't think of it a disorder, but it is, right? Something gone awry. It's if you have burns. The least deleterious, right, or I guess most benign burn would be a first-degree burn. The first-degree burn is really just affecting the epidermis, right? That's really just affecting the epidermis. If you have and you have sort of a reddish-looking color here. If you increase in severity, a second-degree burn, that's affecting the epidermis. I just write that down. It's affecting the epidermis, but it's also affecting the dermis. So it's a much more severe type of burn, and you start to get some blistering then too. Analogous to basically what happens when you're wearing athletic shoes, and if you're running too much, you get that separation between the dermis and the epidermis. That can happen with a second-degree burn, so you see similar blistering. The most severe type of burn is something called a third-degree burn, and this is one that fully affects all layers of the skin. And that is something that the skin may possibly repair itself, but it may take such a long time that really someone needs a skin graft because you're risking infection, and other issues. So the skin possibly can recover from a third-degree burn, but really you're looking at a skin graft at that point. You'll also notice the coloration. Third-degree burns, you can actually have patches that appear white or appear black. So it's a very, very severe type of burn. If a burn patient comes in, physicians will often estimate what percentage of their body was burned. And to do that, they enact something called the rules of 9. And what that is the body is divided in different portions that, basically add up to 9%. So there's 9 areas that are 9% each, right? This diagram is just showing you sort of part of that. And what they do is they estimate based on this, what total percentage of the body is showing a burn. And obviously the higher percentage, the more severe. Okay, what's another disorder we could look at for the integumentary system? And another disorder we could look at is skin cancer, right? That's something that's very, very common. The lighter the complexion of the person, the more susceptible they are to skin cancer, just a scientific fact, right? Due to the differences in melanin, right? Due to the differences in melanin that we discussed earlier. So there's 3 different types of skin cancer I want to focus on here. So the first one is basal cell carcinoma, and that is the least malignant, right? So it's not, if you had to pick one, that's the one you would pick, right? Not that you would pick any, but that's the one you would pick. And it's the most common. And it has sort of sort of a pinkish appearance like that. The next one is squamous cell carcinoma, and that arises from disorders in the keratinocytes of the stratum spinosum, right? That layer that we talked about before, that layer that has that spiky appearance. And then the final one here, which is the most malignant, is melanoma. And this is a cancer of the melanocytes, and it's very, very severe. It's something you want to catch very early on and remove it as quickly as you can. Now, when you're looking for skin cancer, it's very hard to tell if something's skin cancer or if it's a mole, right? Because if you look at melanoma, you might say, well, that's just a mole, right? It's very hard to tell. It's even hard for physicians sometimes. Is it skin cancer? Is it a mole? Are they just freckles? It's very hard to tell. And so to have some type of objective system, they use physicians will use this system called the ABCDE system. In other words, if you have something that looks like a freckle or a mole, but the A would mean is if it's asymmetrical, you might want to get it checked out, right? If it's not symmetrical. If all of a sudden you notice that the border is changing, it's getting an irregular border, you might want to get it checked out. If the color of your mole or freckle changes over time, you might want to get it checked out. If it increases in size, right, diameter, definitely get it checked out. And then finally, if it changes in elevation, in other words, if it starts to get more bumpy than it was originally, in a 3D dimension, sort of coming up away from your body, more superficial, if you will, then you might want to get it checked out as well. Always best to get it checked to be on the safe side. Okay, so those are the three objectives that I wanted to cover today, right? So the skin and the hypodermis, the appendages of the skin, and then disorders of the integumentary system. Remember, before you proceed to the next lecture, you want to make sure that you can execute all of these learning objectives you see here. And if you can, then you're ready to proceed to the next lecture.